windows, and let's see what happens when you increase the size of the tree. You go from, you increase the number of bifurcations in the tree. In other words, your time increment shrinks. You're supposed to get a much more precise answer, so let's see. Two things happen. One thing is the execution time. That's the run time of the tree. The execution time, I don't know if you can see the numbers, but the tree size here is 5. We start with 5. The execution time is about 2 seconds. If you go to a tree of 100 nodes, it runs for 70 seconds on the RT. Usually a good approximation is about 20 to 30. So when we are at about 20 to 30, each run is about 10 seconds. That's not too bad, and we can see how it converges. I'll graph the error here. That's a 0 error. And you see how it fluctuates. That's 0, and that's 20, 40, 60, 80, 100 iterations. Already at 30 you have an error which is less than 1%. Considering the fact that there is a round-off in the market and call and put prices are rounded off to 1/8 of a dollar, a 1% error is not a large error. It's basically negligible. So 30 iterations will suffice usually for computing option pricing. So another thing I can show you right here. This will be a 3-dimensional picture of changing both the exercise price and the sigma, the implied volatility of the stock. I should mention that the call price is a function of 5 parameters. 4 of them are fully observable and objective. This will be the stock price today, the exercise price, time to maturity, and interest rate. The 5th parameter, sigma, is what is called the implied volatility of the stock. That's basically a measure of how much it fluctuates around the mean trend. And sigma is semi-subjective. There are several assumptions that we assume on sigma. The worst of them is that sigma is not a function of time. And anybody who watched the events on October 19 and the way the stock prices behaved on October 19 will know that sigma on that day was by far different than the historical sigma for virtually all stocks on the exchange. So the assumption of invariance is certainly a false assumption. Why do we use it? Because we don't have a better one, basically. But it's a major flaw in this model. Traders in options are doing something very strange. They look at call prices the day before, extract from the call price and the stock price the day before some sigma, and use this sigma for today. So all they sometimes look one day backward and assume that whatever was sigma yesterday will be today. So they don't assume a total invariance, they assume a slow changing sigma. And they are satisfied with what happened yesterday as a forecaster for the future, at least for one day. Any questions about this model? And again, the basic feature here of Speakeasy that I've used is a matrix operation. The ease of handling matrices in Speakeasy. Okay.
And we have some of their papers back there. Dr. Peterson is right here in case you have any questions you can ask him during the break. Our other speakers are available to talk to you. And please, let's only do 10 minutes so we can finish the seminar. Thanks a lot.